function g of x equals 2 over the quantity x plus 3 squared plus 3 is a transformed version of one of our basic functions. Okay, which one? Now we can think of, just take the 5 most basic functions, the squaring, cubing, reciprocal square, and exponential functions. We can eliminate some of those functions. Now, you might not want to eliminate the squaring function immediately because we do have a square here. Might not want to eliminate reciprocal function because we do have a reciprocal with the variable in the denominator. And we certainly wouldn't want to eliminate the reciprocal square function because we have a reciprocal and a square. Well, this then, and everybody pretty well concluded that this is a transformation of the reciprocal square function. So what is the transformation? Well, to transform the reciprocal square function, we start with the reciprocal square function, f of x equals 1 over x squared. And then we can do horizontal or vertical shifts or vertical stretches. Okay, well, in general, if we do the general transformation involving these three things, the form of the function is a times f of x minus h plus k, where h is the horizontal shift, k is the vertical shift, and a is the vertical stretch. So I pose the question, okay, for this function, what is the a f of x minus h plus k function? And it took a little while to get a response. And I said, okay, well, what's f of x minus h? What's that? Well, clearly, if f of x is 1 over x squared, f of x minus h is then f of 1 over x minus h quantity squared. So there's your f of x minus h. Then it's easy to get a f of x minus h plus k. You just put an a in front of f of x minus h. There it is, plus k. This is the form of the function. Now, is this the form of this function? Well, okay. So we summarize. For f of x equals 1 over x squared, a f of x minus h plus k is a times 1 over x minus h squared plus k, which can be written as a over x minus h quantity squared plus k. Just multiply the a into this fractional expression. So what do we have? We have this function, and we have this form. It looks like they're a good fit. Okay, well, for g of x equals 2 over quantity x plus 3 squared plus 3, this function, what are the values of a, h, and k? Okay, we're going to say that a f of x minus h squared plus k is, again, this thing, a over x minus h squared plus k. It's going to equal a g of x function, which is this. Means that a is going to have to be 2. And h, well, negative h is going to have to be our plus 3. And k is going to be 3. So a is 2, h is negative 3, k is 3. Now we know that a is the vertical stretch factor, h is your horizontal shift, k is your vertical shift. So we construct a graph of our g of x function. We start with this graph in white, which is our basic reciprocal square function, and that's something we're very familiar with. Implicitly, this is 4, this is 2, this is 1, here's 1/2. Those are the numbers we need to sketch the graph. And focusing on the points. As a matter of fact, when we first did this, we just transformed the points, and then we sketched the curves to see what the functions would look like. Okay, well, of course we understand this function. The first thing we do is we vertically stretch by a factor of 2, which means we multiply all our y coordinates by 2. So here's the y coordinate of this point. It's this far from the x-axis. So we do an arrow from here to here, and another arrow from here up to here, and now we've doubled the y coordinate. The green coordinate has the same x coordinate as this white coordinate, but double the y value. We do the same here. We do an arrow from the axis up to the white point, stack another arrow of the same length on top, it gives us the green point, the point on the vertically stretched function where a equals 2. And we do the same thing for this point and this point here and this point here and this point here, giving us this green, these green dots and this green curve. And that curve represents 2 f of x. Okay, this is f of x. That's our basic reciprocal function. And these green points represent the points of the vertically stretched, the basic reciprocal function vertically stretched by factor 2, which would be 2 times f of x. All your y values are doubled, and f of x is a y value, so you double it. And you do that, if f of x is 1 over x squared, you get 2 over x squared. So there's your 2 over x squared function. Then we proceed to horizontally shift the graph. We shift it -3 units in the horizontal direction. So we start at these points, we move this point over 3 units, we move this point over 3 units, we get these 2 points on the orange, in orange. Okay? And then we move these 2 points. This point moves over to here. This point moves over here. It actually moves over a little further. It doesn't even stay on the board, so it's over here a little further. We'd get a better shape for the curve if I could have done that. And then we take this point and shift it over 3 units to here. At x coordinate's 2, we shift it over 3. It gets over to -1. Y coordinate is 1, so it's the top of this point at -1, 1. And we shift this point over 3 units. Sorry, we shift, yeah, well, we shifted it. And if we try to shift this green point, it goes off the board. So we end up with at least 5 points on the orange graph. So here's what it is, and you understand what you're seeing. Now this is the graph of 2f of x plus 3. Okay, because the replacing x by x plus 3 is what shifts it left 3 units. And that's going to be 2 over the quantity x plus 3 squared. Well, then we've got one final thing to do. Well, we've got to add that 3. We've got to do the vertical shift by 3 units. So 3 units on the y is about this far, so we take this point and we shift it up this far. We take this point, shift it up the same distance. And we take this point and shift it up the same distance. And then we do the same for this point, and we would do the one that's off the graph, if off the board, if we had it there. And we see that we get this purple graph, these purple points and the purple graph. And the purple graph is then the graph of our g of x function 2 over the quantity x plus 3 squared plus 3. Okay, the 2 vertically stretches the original 1 over x squared graph. The x plus is replacing x by x plus 3, shifts the graph left 3 units, giving us the orange graph. Adding 3 to the y coordinates gives us the purple graph. Now, just another side note that isn't related to transformations, but another way of looking at this g of x function is as a composite. And there are a couple of ways it could be looked at as a composite. Multiple ways you could look at it as a composite. Okay, g of x is 2 over the quantity x plus 3 squared plus 3. I'm saying as a composite of 2 over x plus 3 with x plus 3 quantity squared. In the sense that if h of x is 2 over x plus 3, this function, and k of x is x plus 3 quantity squared, then h of k of x, well, h of k of x is 2 over x plus 3, so h of k of x will be 2 over k of x plus 3. That's what we have here. And then, of course, k of x is x plus 3 quantity squared, so that comes out 2 over the quantity x plus 3 squared plus 3. Okay, this is a big deal. Now, this is a result of a question that was asked when I asked people to submit questions from a set of problems that they were given. And I got at least a couple of really good responses. And this is one of the questions, and I think it's one of the central questions you can ask about functions in a first half of a pre-calculus 1 class.